Hey, Daniel. All right. Rambut cantik. All right, so this is the last class, yeah, about the row reduced echelon matrix. Today we will look into one other example, all right, and we can see how we can do this row reduction. Okay. So this is the one that I give, right? All right. Okay. So let's do another one before we move on. To the next topic. Okay, before that, any question? Before I start, any question at all? If you have any question, okay, anything, probably you have tried some examples that you cannot get it or you're not sure. Okay, one thing is that row echelon matrix is not unique. It's not unique. And the operation is also not unique. Your operation and your friend's operation might be different, right? But we want to go to the row echelon form or row reduced echelon form, and they are also not unique. Okay, so your answer might be different from your friends depending on your operation. Okay, so let's see. Let's see, we have this second example, right? 2, 1, 0, 4, negative 2, negative 1, 1, 3, 4, 2, 0, 1. Okay, everyone focus to the board, okay, to the screen. You cannot refer to anything. Focus. You don't need to write, okay, don't need to write. I want to see whether you can understand and you can share your opinion on suggestion on how we will reduce this to row reduced echelon matrix. Okay, full focus, yeah? All right. Okay, can I ask for a suggestion? Okay, the very first number one rule is that I said, if possible, we want to get this to be 1, right? Okay, if possible. But the most important thing is we want to try and avoid fraction or multiplying by fraction. Although you really like fraction, you really like adding. Okay, so one way to do this, easiest way will be to make this one is multiply by a half, right? But when you multiply by a half, then you will get all fraction. You get fraction here, and then you will adding fraction. Okay, so you see, you have to also look the rest. What do you want is actually to get this one and to make this 0, right? 1 and then 0. Okay, what we do is row operation, elementary row operation. We can also do column operation, but it's not in the scope of this class. I don't want you to do column operation. Okay, we probably think, oh, why not you just do like this? No, just stay with the row operation. Okay, so since this is just a multiple of this is also a multiple of this, so you just make it 0 first. All right, you make it 0 first. So that is why you can just do like this, because they are the same, right? And then some students do like this. I already said for my class, this one is the one that will be changed. You don't need to write this. Okay, no need to write that. If you put that and then something is wrong, you are responsible for that one. So just put this. And some of you showed me your work You multiply again by something. No, you cannot multiply this one. Another student asked me, suruh tanya dalam kelas, tak tanya, lepas tu PM. Which one, number step 1, step 2, step 3, which one, right? This is actually -1 times R3. So it's KRI, yeah? So it is one of those. You can switch the row, you can multiply the row by K is not 0, it can be negative, or you can do KRI plus RJ. Those are the steps, okay? So this is this step, the KRI. Okay, so what do you do? What do you get? You don't change the first row. Okay, you don't change the first row. I can see some of you want to write something. Don't write. Okay, so you add. Add is easy, right? Just add. 0, 0, 1, 7, right? 0, 0, 1, 7. I will always do it at least twice. And then -2 row 1 and add, -2 and add, -2 and add, -2 and add. Okay. All right, now. Okay. Okay. Now you can change this to 1 because you are done, right? You are done with making this all 0. So you can just multiply. Okay, you can just multiply and you will get. Okay, I just copy. Yeah. Okay, and then 1 over 2, 0, 2. Okay, now where is your leading one, right? So you find your leading one. For the first one is this, and go here, and then the leading one is this, right? And we are lucky because this is already 0, 0. This is already 0, 0. Okay, the last one will be this one, right? You want this to be 1. So you need to multiply by, don't be scared to multiply by a fraction. This is already at the end. Okay, so you can just multiply by fraction. So this is already at the end. Okay. So 0, 0, 0, 1. Right? This one copy. Okay, this is already row echelon matrix. Why? Because the leading one in every row, yes, they're all 1. And the leading one underneath is to the right, right? Or the one before is to the left, tetanggakan. And everywhere else, down here, there's nothing. But this is not reduced yet, right? Because you need these two to be also 0. So one more time to get the row reduced. So the last one would be using this here. So -2, row 3 plus row 1. -7, row 3 plus row 2. You can do this at the same time. And then you will get, sorry, my matrix becomes smaller because, oh, sorry, I start from here, yeah? Want to fit that. Okay, so -7 plus, this won't be a change. But these are all already 0. You just add -7 plus, okay? Why is it so far? One and a half, 0, and right, -2 and add 0. Okay, so this is REN. Because you put the leading one and then Everywhere else are zeros at that leading one column. Okay, don't worry about this because there is no leading one in that column, right? This leading one in the first column, you go to the second row. This leading one is in the third column, go to the third row. This leading one is in the fourth column. Okay. Okay, any question? Gelak lah Eugene. If you have question, ask question. You can raise your hand. Tak ada ya? Tak ada. Okay. Okay. Let's move on. Okay. Okay. Next is the definition of rank of a matrix. Very easy. The rank of the matrix is the number of non-zero rows in the row echelon matrix or row reduced echelon matrix. The number of non-zero rows. Meaning if I give you a matrix, I want you to find the rank, you need to reduce. You need to do the elementary row operation. Okay, by the way, this is in your notes, yeah? Don't have to copy, it's in here. I think I did exactly the same. Yeah, but this one, I just do it once. You can combine actually, this and this. Okay, so if you are given a matrix, the question is to find the rank. You know what you have to do? You have to reduce into row echelon or row reduce. And then you just count how many non-zero rows. 1, 2, 3. So you will write the rank is, this is the symbol for the rank, row, call this matrix A is 3. You don't need to go until row reduce because they will have the same rank. Okay, so depending. So this is the rank. Okay, you can go through the examples. You cannot read. You cannot read the example. You had to redo. You cannot read mathematics. Okay, so that's a example. Find the rank of the given matrices. So if you follow through, you will get the rank of E is 2. For the F, follow the example. For the F, oh, it's in the exercise, yeah? By example 129 and exercise 4 in the soft copy. In the book, it's in the example 1.29. It's a little bit different because I put on some spaces and ask you to fill in the blank. If you already buy the book, then it's already there with the answer. All right. Later on, we'll have more example and more exercise on doing elementary row operation. But you have to try. You have to try as many. Yeah, Hikmah, what's your question?
Medi, yang tadi 1/2 tu kenapa Medi cakap boleh biarkan je?
Bukan biarkan. This one, okay. I said this one, you can combine at the same time and do this here. As in the notes. Bukan biarkan.
Bukan Medi, yang last kali tu, RREM.
Oh, this one? Oh, sorry. Ingatkan yang ni. This one, memang kat situ lah. You don't have to do anything. It's okay to be there because this is the leading one, right? In the first row, in the first column. When you go to the second row, the first non-zero number is this, right? The first one, it's not here. Tak boleh ubah, eh? So we just leave this. This is okay. It doesn't matter. It doesn't mean that your every column has to be zeros. No. It depends on whether you have the leading one or not. If you have the leading one, then the rest has to be zero. You go to the second row, you go, where is your leading one? It's in this column. So this is the column that you have to make it 0. Okay, so you can actually skip, it's okay.
Oh, faham tu.
Right?
Thank you, Madam.
All right, any more? It's a good question actually. Okay, Jaya. If I start with fraction, is it wrong? Tak, saya tak kata salah. Nak start dengan fraction? Nah, okay, jom. Siapa ni namanya? Mana dia? Angkat tangan, Nurul Hamizah. Angkat tangan kat situ. Ah. Tak nampak dah lah video off. Okay, boleh nak start dengan fraction? Boleh. Jom. Okay, semua boleh menulis. Saya takut nak menulis. Okay, you want to start with fraction. Hamizah, what's the first one? Bagi saya dia punya langkah.
First one saya buat 1/2 R1.
Okay, 1/2 R1, yeah? Okay, so you will get 1/2, 0, 2, right? Then you still get this, right? Copy, yeah? Okay. What's your next one?
Next one I 2R1 plus R2.
Okay, then?
Bawah -4R1 plus R2.
Right. Okay. Okay, so we will do copy. Okay, 2R1 plus R2, 0, 0, 1, 7, right? Right? Betul tak? Hamizah? Betul tak yang lain? Betul tak? Betul tak? Okay. Plus 0, -4. Lambat kan? Nak dapat kan? Itulah siapa suruh. Okay, -2, -4 times -4 times and add. Right? Okay. Okay, okay. For this particular example, it is still okay because they're all like even that you can divide. You think about if you divide by 3 and then add, it becomes more complicated. Kan? Tadi dapat tempias sikit je. 1/2 times 4. Kan? Dia tak ada teruk sangat lah. Still bearable for this one. Tapi lambat juga nak tunggu you all ni. Okay, then you just do this as before, right? And then another one, yeah, making this 0 and 0. So you don't really see the impact in this particular example because when we do this and we multiply these numbers, they are all even, so still okay. Yeah, Miza? So it's not wrong. Then you see the difference. Tak nampak sangat difference in this particular example because even though we divide or multiply by 1/2, still when you multiply back by 4, it's just a round number, integer, yeah? But my advice, tak nak ikut tak apa. If you like fraction, as I said, you can start the beginning with fraction. Okay, any other question? That's good. Okay. Okay, if you raise your hand and I didn't see it, kena unmute lah ya, nanti tunggu lama, raise hand situ, raise hand sini, kena unmute. Okay, Miza, okay. Test. Okay, next one is determinant, yeah? You have seen this by 2 by 2, 3 by 3, I think during school.
Professor,
Yeah.
Hamizah punya soalan dia hantar ke chat box. She said,
okay.
if I start with fraction, is it wrong? Question mark.
Tadi kan saya dah jawab. Kan? Saya dah jawab, tak salah. Right? Mana Mizanya? Miza? Okey tak? Jawapan saya dah jawab belum? Hilang dah.
Dah,
Mana?
doktor. Dah.
Dah. Okey. Ada
Nanti
kawan
dah.
awak ni. Dia nak support ni. Saya tak jawab soalan ke?
Thank you,
So the
Prof.
answer is it is not wrong. Yeah? It is not wrong. Okay. Ataupun dia saja-saja je nak mendengarkan suara dia. Okay. Determinant of a matrix. Okay. All right. So determinant is actually, you never think about this as a function, yeah, determinant. Determinant is actually like a function that transform a matrix to a number. That transform like n by n matrix to a real number, or we don't really do complex in this class, just a few of the type of matrices that we have complex. Okay. Now, before I define determinant, let me define a minor. Okay, first, what is a minor? Okay. Now, our world is only for n by n matrix. Okay. Don't create a new formula to find determinant for m by n matrix. It has to be square. Okay, so minor is for like A, B, and n by n matrix. Square matrix, yeah? Okay. Then the minor for the n3 Aij is the determinant. You're looking for determinant and then minor use determinant of the submatrix before this we learn about submatrix, right? By removing rows or columns, okay, if you remember. That remains after deleting the ith row and jth column. Quite complicated to understand, but it's not that complicated. Okay, so we say the minor of Aij is denoted by M sub ij, yeah, the submatrix M sub ij. Okay. Now, before we look at the example of this whole thing, we have to look at what is the determinant, right? What is the determinant? And the definition of a determinant okay, it is a scalar. Or we put determinant of A. So that's why I said it's like a function. Oh, I cannot use this. It's like a function, which is actually this determinant from m by n matrix to the real number. Okay, this determinant, in which we transform f of A is determinant of A, or we write like this. Actually, it's a number. And how do we do this? Is by the formula of determinant, right? I can see in your quiz 0, many of you still remember to find the determinant of 2 by 2 matrix because the inverse is 1 over the determinant, right? The one that you still remember. Okay, now that is the first one. If you have A is like A, B, C, D, okay, then we write determinant of A or determinant. Let me do this square so you can see the difference. Determinant of A, B, C, D. I just read out all kind of symbols that you can use as this, which is like this, right? Because you can use that, or you can write determinant of a matrix, or you can just write this. And some books, they just write like this. Without the bracket, the matrix, they just put like this. That means this is a matrix. And this is a equal. Daniel, what is this equal to?
AD tolak BC.
AD minus BC.
BC.
And if they're all entries reals, you multiply 2 real numbers, they are reals, you subtract another real number to a real number is also real. That's why it's a scalar, it's a real number. Okay. Now, what if I do this? What is the determinant? Do you learn this during school? Tak ada. Macam ada je. Tak ada. Betul tak ada? Ada kan? Nah, Miza ada? Miza. Okay. Farhan. Siapa lagi ada? Okay. Let me call Farhan. Tadi dah ni kan. Buat kandang. Kandang apa? Lembu ke ayam? Farhan mana? Angkat tangan. Okay. Farhan tak nampak muka, boleh ke onkan sekejap? Unmute kan sekejap. Okay. Can you help me, Farhan? How do you get this? Speaker tak molek. Okay. Cuba cakap je. Kita dengar molek ke tak molek. Tak ada bunyi Auni dah geleng-geleng dah. Auni tolonglah Auni. Speaker tak molek. Tak dengar. Okay, Auni tolong. Auni angkat tangan Auni. Tak dengar lah Farhan. Sian Farhan. Okay, barulah nampak kat atas tu. Okay, you can unmute. Okay.
Dengar tak?
Yes.
Dengar tak?
Dengar. Okay, can you help?
Soalan dia apa, Doktor?
Macam mana nak cari determinant? How do you find determinant of 3 by 3 matrix? Did you learn about this before?
Learn, tapi
Tak ingat?
tak ingat.
Okay. Alright. Okay. It's okay. If you look at the notes, I give you the whole formula. Okay. This is what I learned. Right? This is what I learned. Then you can share with me kandang tu macam mana. This how you learn it. Okay. So what I learned is I add up 2 columns. Yeah, I don't know if you learn also like this. I add up the first 2 columns. This can only be done for 3 by 3. Okay, because probably in one of my classes I didn't say this. the student add 3 column for 4x4 matrices. Suka hati je kan buat formula sendiri. No, you can only do this for 3x3 by adding 2 columns. All right. And then what you do is you multiply diagonally. You multiply diagonally and you subtract the other diagonal. Okay, so let's multiply. So you get AEI plus BFG plus CDH, then you minus CEG minus AFH minus BDI. Okay. Okay. This is only for 3x3. Before this, we see 2x2. So in this class, we go higher and higher. Okay, we don't restrict 2 or 3. We can go, I can give you 100 by 100 matrices. Tahun depan baru habis kira. Tak semestinya. Okay, I can give you higher and higher. Okay, let me share one more method that I use that I have been taught by my TA. I had a teaching assistant during my algebra class, which is a PhD student also. So we have 3 hours of lectures and then another hour of tutorial. So the tutor is a PhD student. Okay, this is what he taught me. You remember which year I taught linear algebra? I mentioned during the first class. 19, awak semua tak lahir lagi kan? This is the year I took linear algebra. Berapa tahun ni? Kan? Betul ke tidak kita? Betul. Alright. Okay, let me rewrite ya. I like this method because I don't need to add 2 columns. I can just do it in my head. If you can do it in my head, in your head. He's actually international student, not from US. I was studying in US. He's, I think, from Russia. Yeah, that's how. Kausalya, which method that you know? This method or the method that I haven't cancelling just now? Okay. After this, you tell me whether you have seen also this method, the star method, I call it, star method. Okay, first, I draw like this, and I draw a triangle parallel to this, which is, okay, the base is parallel, and the other one is this. So this will give me AEC, and then parallel, BFG, and then CDH. Okay, that one. Then the other one is the other, wait, this, right? And then parallel to it, parallel to it. Pening tak? Okay, so I minus the other way around, just not here. Here, yeah? CEG minus BDI, and minus AFH. Okay, and AEI. Saja je nak tengok, cek tak? Gitu. Ada yang padam, ada yang salin. Salah salin. Okay, thank you, Vinita. Actually, just now, 10:40, I was in Canada. gitu. In virtually, somebody knocked on my door to get the notes. So I was in session for 1 hour. I supposed to this virtual kan sekejap. Okay, anyway, you don't have to worry. You don't have to follow this. I'm just sharing. This is another way. Jangan pening-pening. Muka berkerut je. Yang off video pun saya nampak muka berkerut. Okay. Okay, okay. Alright. Okay, anyhow, this is how you can find the determinant of 3 by 3. But read the question very carefully. Or not this one, you use another method. If it's square matrix. Yeah, this is square matrix. Okay, this is square matrix. Okay, then after this, I will give you the formula to get a determinant of the higher order. 2 by and 3, you can use this. But if the question use elementary row operation to find the determinant, you have no choice. You cannot use any other formula. So you have to read your question very carefully. If the question just find the determinant and the question gives you 3 by 3, then you can use any method. Okay, method is important. Although the answer is right, I know you can also find by calculator, right? But you probably will get 0 if you don't use the right method. To check your answer is okay, but I want to see the correct calculation. All right. Okay. This is also in the notes, so you don't have to write, just listen. We want to find all minus. Yeah. So just now we talk about minus. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The question is to find all minus of A. Okay. And minus, remember, Mij is the determinant of the submatrix when we delete row I and column J. That is minor. Okay, the determinant. So how many Aij you see in here? How many entries? How many entries? Type. Apa ada serangga ni? How many entries in this matrix? How many? Mana tak ada siapa type ni? Okay. 9. You see 9. If you have n by n, how many entries? If it's n by n, how many entries? You type. You know the right formula to type for the superscript is this. This means this. This is the right. Later on, maybe you will learn about how to type in LaTeX. This is not word. This is what normally mathematician will type in. It will be nice if you type in there, and underscore is subscript. Okay, anyhow, pergi ke lain pula. All right, so you have 9 times. If not, if n by n, you have n squared times. So you will write M11, M12, wait, let me just follow the row. Sorry. Okay, I follow the row, 1, 1, 2, 1, 3, 1, okay. And then I have 1, 2, 2, 2, 3, 2, 1, 3, 2, 3, 3, 3. Okay. So this is the determinant of a submatrix when I delete row 1 and column 1. Delete. So you will get right? Okay. Delete row 1, column 1. So this one, delete row 2, column 1. This one you delete row 3, column 1. Okay, then you fill in the rest. It's there, so I'm just showing you 3 of them. Yeah. Dot, dot, dot. Let's try the last one. 3, 3, 3, 3. So 1, 2, 4, 5. Okay, and then you remember 2 by 2. You just do AD minus BC. So this is 45 minus 48. 18 minus 24. 12 minus 15. Okay, and last 5 minus 8. So this is the minor. Okay. 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 All right. Okay. Now, from this, we define a cofactor. Okay, we define a cofactor. Okay, so let me write out, copy, yeah. You can see from the notes. Okay, now we go to the cofactor of a matrix. Right. Cofactor of a matrix. Okay, still let A be an n by n matrix. This is very important. You don't talk about any rectangular matrix, just a square matrix. Okay, the cofactor is also a scalar. The cofactor Cij is a scalar such that, okay, Cij is equal to -1i plus j mij. So you see there is a ij, right? Okay, Cij is -1 to the I plus j mij. Okay. -1 can take a power of -1 can take only 2 values, right? -1 to the 1 is -1, -1 squared is 1, -1 cubed is -1. So it's 1 -1, 1 -1, right? So this is positive mij if I plus j is even, right? -1 to the even number is 2k like this, right? So that is a proof actually why -1 to even is 1, because you take the 2, you become 1, so it's 1. And if it's to the power of odd, right, to the +1, then you have this, and then you multiply by -1. So you multiply by -1, it is -1. If I plus j is odd. That's the only difference in between minor and cofactor of a matrix. Okay, so from this, I can write the cofactor of this. So this C11, I write here, yeah? C11, C21, tak muat. C31, C12, C22, C32, C13, C23, C33. And you see, this one is positive, right? 1 plus 1 is 2, so it's the same, right? And this negative, so 6. And this positive, so it's the same. And this is negative, so it's 6. Positive is the same. Negative is 6. Positive is the same. Negative is 6. Positive is the same. So if you look at this cofactor of 3 by 3 in a matrix, you see this is like a checkers. Up and down, yeah? Where you have plus, minus, plus, minus, plus, minus, plus, minus, plus. Right? Or if you want to do 4 by 4, right? That will be like this. So this is like checkers. Okay, so we are done with the minor. We are done with the cofactor. Now the next one is a cofactor matrix. Cofactor matrix. Okay. The cofactor matrix, still we will write A is an n by n, and we call the cofactor matrix to be C. Yeah, cofactor matrix of A is C, which is Cij. Okay, so you just take all these numbers, put together, and becomes a matrix, and it is called a cofactor matrix. Okay, so for this particular one, I just copy -3, 6, -3, 6, -12, 6, -3, 6, -3. This is the cofactor matrix. Okay. Okay. That is the answer for exercise 6 in your e-learning notes. Okay. Or you can just refer to your complete notes. Okay, now we are ready to define the determinants. Okay, to define the determinants for any dimension of matrix, not necessarily 2 by 2, not necessarily 3 by 3, but any dimension. Okay, so now we go back to the determinant of the matrix. All right, so let A be n by n. I don't write again, right? A be n by n, then tulislah. The determinant of A is equal to sum A1J C1J, J1 until n. Okay, this is called using the method of cofactor expansion of row 1. Okay, this is called the cofactor expansion of row 1. Huh. What does it mean? This is the sum. This is the sum of the product, right? What is this? This is the entry of A multiplied by the cofactor just now, right? Or cofactor. But you don't choose all 9. You just choose just particular row. Actually, we can also use particular column. All right. But let's stick with row first. Cofactor of expansion of row 1. Okay, suppose we look here, yeah? So for this particular one, 1 times 1, 1, right? When j move from 1 to n, you get 1, 1, 1, 1. 1, 2, 1, 2, 1, 2. So it's always 1, 1, 1, 2, right? So you take 1 times -3 plus 2 times 6 plus 3 times -3. 1 times -3 plus 2 times 6 plus 3 times -3. What's the answer? What's the answer? 0. 0. Ay, penat kira dapat 0. Let's try the second row. Let's try the second row. Okay. 4 times 6 plus 5 times -12 plus 6 times 6. 0. Iya aja. 24 plus 36 is 60 minus 60. Yeah? This is your method. Kendang method. Okay. Ingatkan kandang tadi. Oh, betul lah kandang. Okay.
Yes, kandang, madam. So you just section it out into 4 boxes. In this case, it's 9 boxes.
Oh, okay. I don't call it kandang method. I call it cofactor expansion. Or you can take the third one, right? The third row, 7 times -3 plus 8 times 6 plus 9 times -3. So -21 and -27 is 48. -48 plus 48 is 0. This is just to check whether they are the same in taking any row, but you don't have to use all rows. Why? You just need to find the determinant, right? So you just pick any row or actually any column that can also do. Okay, so my question is, if you have probably another matrix, which column or which row that you want to pick to find the determinant? I would choose row 2 or third column, because when A is 0, you don't even have to check the C, right? More 0, that's right. So let's try and calculate this. I give you 1 minute and then we take a break. Find the determinant of this matrix using cofactor expansion of any row or column. One minute. Okay, any volunteer? Any volunteer? Kat tangan, kat tangan. Arif. Okay, Muhammad Arif. Raise your hand, please. Mama Arif. Angkat tangan, angkat tangan. Raise hand supaya saya. Okay. Alright. Okay. So, nak pilih row or column mana? Which row or which column? Okay, this one, yeah? Okay. So, this is plus minus. And I will start with plus minus and I will take the M, right? So this is, I put like, or you can do like this. 4 times C2, 1, right? Plus 0, C2, 2, plus 0, C2, 3. You don't really have to even calculate this, right? Because they're all zeros, forget. And then for this one, it's negative, right? 2 plus 1 is negative. So negative 4, then you have to calculate M to 1, right? M to 1. M to 1 is by taking this out. So 2, 3, 1, 0. Then you get negative 4, negative 3, which is 12. Okay, saya pula bagi jawapan. Arif angkat tangan je. Okay, you can lower your hand. Okay. Right. Okay, another one. Someone is also want to do. Oh, I forgot. This is important. If you want to do this, you do like this. Or you do like this. So I know which row that you pick. Yeah? Easy for me to grade. So all you write out. Cofactor of row expansion row 2. Otherwise, it would be hard if I had to figure out and your answer is wrong. Okay, now let's try third column, right? So you will do 3, right? Plus, minus, plus. So 3, and then I just cancel 4, 0, 7, 1. So this is 3 times 4 minus 0, which is 12. You have to get the same answer. All right. If you like to be complex, you don't like a simple calculation, you can choose row 1 or column 1. Menyusahkan diri kan. But you can also choose any 9. Any 9. 3 of this, 9 pula. 1, 2, 3, 4. Any 6. There are 6 different ways to find the determinant for 3 by 3. Okay, any question before we break? Okay, Rauda, what's the question?
Prof, jadi maksudnya walaupun kita buat any 6 tu semua tu, kita still akan dapat 12 ke jawapan dia?
Yes. Okay, determinant is unique is a very good question. Determinant is unique. The calculation is not unique, meaning there are many ways to find it, but determinant only one answer. Okay, just now row reduce, row echelon matrix, they are not unique, but the rank is also unique. Yeah, the rank is also unique. Determinant is also unique. Okay, dah boleh lower hand ke ada soalan lain? Okay, any other question? Okay, before your registration. Attendance is shared again. Please help me share, Hana ke Shiham, the weekly schedule. Can you help? I just want to mention a little bit about our course outline, the weekly schedule. I'm trying to follow it very carefully. Yeah. Ada tak, Shiham?
Kejap.
Okay, so we are already in the second week, yeah? And we are already there. So I have started a little bit early. I went into rank of a matrix and determinant of a matrix because next Sunday is a holiday, right? Next Sunday is Ramadan. So senyum aja. Happy Ramadan. On Sunday, we don't have class. We will have class on Tuesday. Okay. Then I can go into probably more on the determinant of a matrix and inverse of a matrix. When we have more time to keep in track of this, I will go more on the example, but I need your cooperation. Okay, I need your cooperation to do as many exercises and do the examples that I skipped. The examples are all in the notes. They are provided there to cover as many cases that is possible. Okay, I put in all kind of examples. So you have to understand and try all and redo. Okay, my suggestion would be to take that question, try, and make sure you get the right or the same answer. Okay, don't copy, because then you will see what kind of difficulty, why you cannot reach to this, then you refer. This is how you should read the notes. Yeah, and also try the exercises at the end of the chapter. Shiham, we have the exercises also, right? At the end of the chapter. We'll check again later in the notes that we share in the e-learning. Okay, you have to do all. And I already put quiz 1, right, on Tuesday, next Tuesday. In the, if you check in the, what do I call it? The Google Calendar, right? And I put in the notes that we will have the, probably later on, we will add this quiz 1 for week 3 on Tuesday. We can stop sharing, Shiham. Thank you. Lama betul Prof Niza ni nak break kan. Kejap. Oh, it's not in here, but I already put when I create. I cannot find it here. But anyhow, okay. Tak tahu kat mana nak cari dah. But I put in the notes that there will be a quiz 1 at the end of next Tuesday's class. 15 minutes, 2 questions. It will cover type of matrices and also operation of matrices. Just 15 minutes, just 2 questions, and it will be 10 marks. You remember the whole quizzes will comprises of 20 marks in the whole of the semester, not counting quiz 0, yeah? That's baru warm up. So it will cover the type of matrices and also operation of matrices. That 2 only for 15 minutes. And I will give you the last 15 minutes during class on Tuesday. And for you to have time to upload your answer in the e-learning, I think 5 minutes should be okay. Should be just 1 or at most 2 pages. Okay, clear? Okay, so we take a break. 12:07, 12 we come back, yeah? 5 minutes. All right. See you later. Determinant. Right, thank you. Let's try one more. Okay, let's try one more question to find the determinant. Okay, this is also in the notes, so you can just look. Yeah, just look and understand. Okay, this is the question, yeah? Find the determinant of a matrix 3, -7, 8, 9, 0, 2, -5, 7, 0, 0, 1, 5, 0, 0, 2, 4. Okay. Okay. So what we want to do, is the cofactor expansion. Cuba type, awak nak pilih yang mana? Jangan tengok nota. Just look at the whiteboard. Which row or which column that you want to choose? Type. Okay. Okay, Daniel Hakim. Okay. Majority, ya. Okay. Senang aja bagi jawapan sama. Mana boleh sama. Ngelat. Alright. So first column. So I will write 3, right? Because this is 1 start here. And then, right? And then I will write 2, -5, 7, 0, 1, 5, 0, 2, 4. Jangan sibuk nak menyalin. Look here, because later on you will miss some of the information, right? So 3, and then the rest, right? Okay. But you also have the others, don't forget. 3, and then show this. Plus 0, -0, +0. Saja nak tunjuk lah. If you want to write, you can write times C21, right? C31, C41, but it's optional because I will know that you already know. That's why you choose column number 1 because they're all just zeros. Okay. If you miss this and it's not 0, itulah markah nanti banyak lah dibuang. If everything is okay, it's okay, right? Okay, next. Type again which column or row that you want to choose. Okay, let me see. Row 1. Row 1. Column 1. Column 1. Okay. Don't forget this 3, yeah? Don't forget this 3. So column 1. So I will put the 3 there. And then the 2, right? The 2. And then whatever you see the 2, cross. What's left? 1, 5, 2, 4. Okay. Next, which one you want to choose? Which row or column? Fahanis ada tapi tak nampak cakap apa. You were saying something. Fahanis, unmute. I want to hear what you said.
Data saya tanya mana datang 2 tu.
It's 2 by 2 kan? Nak menyusahkan diri lah, nak column lah apa. D minus BC,
Okay.
it's 2 by 2 already. Okay, thank you. So this is 6 and then 4 minus 20, right? So 6 times minus 16. Right, so we want to write until it's way down. Yeah. Betul lah. Alamak. Jangan marah. Okay. So 6 times -6 is Saja je, tengok you all ni alert ke, salin aja semua ke? Itulah. Okay. Alright, so this is the matrix. Okay, sometimes you don't have a choice. Just choose smallest number if possible. If there is no zero, right? Probably better to choose smallest number. Okay, now let's try another one. This is also in here. Oh. Okay. Yes, if there is no zero, like the very beginning, right? My very first example, no zero, right? So you have to choose any row or any column. Okay, so choose the one that have probably sometimes you don't have a choice, but try to choose, probably if you have fraction, don't choose that row or that column. Yeah. Okay, so this one you can choose any, right? Okay, what do you have? Type. Column 1. Okay. Australia dah wakil. Somebody wants row 1. Okay, if you choose row 1 or column 1, it will be similar, right? Row 1 pun sama. Okay, so you will have 1, and because this or this, I can put this, right? The same. But once you choose that one, the rest are all zeros, right? So don't forget, because every time Proniza just cancel all zeros, then you forget. So the rest will be 2, 0, 0, 0, 0, 3, 0, 0, 0, 0, 4, 0, 0, 0, 0, 5. Again, right? You do this again and again. I just showing you, right? And then again. 3, 0, 0, 0, 4, 0, 0, 0, 5. And then again. 4, 0, 0, 5. And then again. Actually, right? 4, 5. So coming the property of the determinant of this, that if the matrix is a diagonal matrix, the determinant is the product of the diagonal entries. Yeah, because of this, because we do once and then once and then once and then once. So if you have a diagonal matrix, this is a diagonal matrix, right? One of the matrices, the type, and the determinant is the product of the diagonal entries, right? So in other words, if you write the diagonal matrix as, this means the diagonal with diagonal entries, I from 1 to n. Then the determinant of this matrix D is the product of lambda I from 1 to n. Okay, mathematicians sometimes they want to make things complicated, right? They write in symbols so other people don't understand. Although actually you can just write the D as this, all zeros here. So D is, right? They are the same, but this nampak canggih kan? Nampak susah. Actually, it's just the product. So this is product of all the lambda from 1 until n. Okay, this is a property. But this is actually proof using the row or column expansion. Okay. Now we go and look at the That is theorem 1.2 that I put in the notes. Yeah. Okay. Right. Properties of the determinant. Okay. Sometimes the question given in the test, in the quiz, or in the final, they ask you to find the determinant using the properties. Meaning you cannot use definition. You cannot use cofactor expansion, row or column. You have to use, they force you to use this property. So you need to know and you need to state what property that you use. Okay. All right. Okay. Number 1. So we put properties of determinants. Number 1. The determinant of A and A transpose is the same. Okay. Then you have to think why. You have to think why. Because you take determinant row and column, you will get the same answer, right? And transpose A and the transpose, the difference is just the row becomes column, column becomes row. So the cofactor expansion finding the determinant is just choosing any row or any column. So you will get the same answer. Okay. Okay, you can look at the example yourself, but I will show you later on why we putting this, because you can just use any expression, you will see why. Okay. If you have a matrix A and then you do elementary row operation to this, and you get a matrix B, and this elementary row operation is by exchanging the row, okay? The determinant of B is actually the negative determinant of A. Okay, I'm not gonna go to the proof, but the reason is because of the I plus J, right? In the cofactor expansion, when you change, it becomes the negative. Okay. Let me just give you the example before I erase the property. So if you say given A, B, C, D is 3, find, I better put this so you see it's a matrix. A, B, C, D. Right? Suppose you're given something like this. This is how and when you should use the property. Because you're not given the matrix, you're given the condition. So A, B, C, D is 3, you know, yeah, AD minus BC is 3. So this one is AD minus BC also, so it's 3, but this is 2 by 2. But if I give you a very big matrix, right? So since the determinant, this is the transpose, right? This is just the transpose. Since you write like this, then you say the determinant is the same. Give your reason, right? Because this is the transpose. Okay. Laju na Nabila kan pening. Okay. Okay. All right. Now, what about this? Okay, fine. This is for number 1, right? Find the A, B, C, D. Right? You probably will do like BC minus AD, right? Is the negative or AD minus BC, but it's the property that this is switching, right? Switching the original. So you will write this. There are 2 ways to write this. Let me do this. CD AB okay. Let me write CDAB like this is negative. Okay, I put R1, R2, A, B, C, D. Right? Because changing this, right? Negative here. That's negative here, which is equal to negative. This is the original given. Yeah, this is negative. This is one way to show. The other way to show is from the beginning. A, B, C, D. You do R1, R2. Then you get A, B, C, D. Many students like this way because they can easily see what do you do with the original to get the new one. Okay. You see this, right? This is the matrix part. So then you put therefore, right? Therefore, right? Because you change this, the determinant of this is negative because of this and because of the property. Then you get the determinant, this is the negative of this actually, which is equal to 3. So it's negative 3. So you see the difference. This one is directly know what you should do to get to the original. This one is from the original because the original is the one that you are given. What do you do to get the question? Okay, anyhow, you will get the same answer. Okay. All right, that is number 2. And you know now why I have to be strict with the operation or the elementary rule operation, because we will use the property to find the determinant. Yeah? Okay, number 3. Number 3. If you have A and then B under ERO and the operation, oh, this one I skipped number 3. That is number 5 already. Oh, it's okay, it's okay, it's okay. This is number 5 in the notes, but I don't want to erase. I will put number 3 and 4 here. Yeah, jangan marah. Okay. Sebab nak ada feeling ERO dia kat sini. If this is KRI plus RJ. Okay, in here we call it number 5. Hashtag tak sabar. Okay. Then the determinant are the same. Amazing kan? Tak percaya kira lah. Okay, if you follow this, you do ERO, the determinant is the same. So if we have a matrix with not many zeros, right? If we do like 1 or 2 ERO to get many zeros, then it's much easier to get or to find the determinant. You see where we are going? Yeah. Especially the first example. So many things to calculate. What if we just take the leading one there and make everything underneath is 0, right? And then the AI times CJ, all the AI size 0, just do once. Okay, so if you change suka hati, you put your own KRI plus K2 RJ, you won't get. You won't get, it will be wrong. Okay. Go back to number 3. If they exist, they exist. If they exist the same row or the same column, then the determinant is 0. Okay. For example, that's why I said I can give you 100 by 100, right? Matrix, and you can find the determinant. Probably they're all zeros, right? Or probably they're all like diagonal. So in this class, we don't restrict to only like 2 by 2 or 3 by 3, right? So as an example, if you have like 1, 2, 3, 0, 1, 2, 1, 2, 3, I know this is 0. By the property. Cepat gila kira kan. Which actually, you can use this, right? If you use the row operation once, negative row 1 plus row 3, because they are the same, right? So negative row 1 plus row 3 at one time, you will get 0, 0, 0, right? And then when there is rows of zeros, you just pick that row, then they all 0 times 0 times 0. So that comes to number 4. If A has a 0 rows or more, right? A 0 row, then of course, right? You just choose that to be the cofactor, and then they're all zeros. 0 times this plus 0 times this, okay? Then the same reason why this is 0. Because then you will do one row operation and then choose that row and they all become 0. Okay. This last one is very important. You have to be very careful with the last one. Okay, this is number 4. Number 6. Now, you have A, and then you have B, you have ERO, and you have KRI. Okay, meaning you change by multiplying, right? By multiplying row by scalar. Then this is K times A. Okay. So interchange row, negative. Multiply by scalar is multiply the determinant by that scalar. Use this operation, does not change. Okay, so this is by row operation. What about this? What about B is KA? This means you multiply every row by K, right? What is the determinant? What is the answer? You can type. Or you can unmute. It's not KA, but row 1 you multiply by K, row 2 you multiply by K, row N you multiply by K. K, 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 K for that rows. So it's K to the N for N by N matrices, right? So be careful, right? It's not the same as multiplying matrix by the whole K to the whole matrix or just row. Okay. All right, we are done with the property of matrices. In this one, I give you some exercises. Okay, and examples. Okay. All right, let's go to this exercise. Find the determinant using properties of determinant. Okay, I give you 5 minutes. 5 minutes. No, it's 44. Okay. Okay, which property that you want to use? Anyone? Okay, which one? If try to see whether there are any same rows. No, right? No same rows, no same columns, not diagonal. So meaning we have to probably use row operation because we cannot use the expansion formula and others. Okay, I missed two parts. Actually, not only diagonal, but upper triangular and lower triangular matrix. The determinant is also the product of the diagonals. Yeah, for the upper triangular matrix and lower triangular matrix, the determinant is the product of the diagonals. So let's do don't change interchange row because it will change, right? So try as much not to do the other operation except for row operation, the K, Ri plus Rj. Okay, let's try that. So if we do this like R2 plus R1, okay, this will give, right? You don't change the R2, okay? You don't change the R3. So R2 plus R1 will make this one, right? Will make this one. So you put 1, 2, 2. Okay, this is just do row operation first. So I want this to be 1. If I change, I have to remember that I changed later for the determinant. That's very dangerous. So I just try to do the KRI plus RJ. Okay, so I just add. This is like 1 R2 plus R1, right? So this is K R2 plus R1. Now, you see, this is already 1. You can make this and this 0. Right? Easy. So you just do R1 plus R2, negative 3 R1 plus R3. Then you get 1, 2, 2, 0. Just add, right? Negative 3 and add. Okay. Still, you cannot use the cofactor expansion. This is not property. Okay, there is another why. Because the question asks you to use the property. So now I want this to be 0, right? But how do I get this to be 0? If you multiply by k, 1/4, then you have to change the determinant. Right? You multiply by k, so I don't want. I just want to use the KRI plus RJ. So what I will do is I will add, right? You can add. You can make this with this, right? There is a 5, you can add. Okay, how do you add? This is the long way actually. There is a shorter way just take this. You know already the answer, right? Take this and then the determinant, right? But that is not the property. Okay, let's try this. Let's try and see whether how do you make this one. Probably I just do this to show you. Okay, and then this is 0, negative 1. Just add, right? Right? Just add. Okay. I don't say that we want to reduce to row echelon form. We want to reduce to diagonals or upper triangular or lower triangular. So it doesn't have to be 1 at the diagonal. I want this to be 1, so it's easy for me to make this 0, right? For this one, you can just leave like this because this is easy, right? You can just multiply this and add, right? Because this will be 0. That is what we want. Okay, so we will get 1, 2, 2, 0, negative 1, 1, 0, 0, negative 7, right? So you see, these are all the elementary row operation, KRI plus RJ. And now this is the upper triangular matrix. So the property that I put just now for diagonal, you have to add up, yeah? Also the same for upper triangular and lower triangular. The determinant are just the product of the diagonals. Okay, so the determinant of the original is equal to determinant of this one. I don't copy yet. I don't copy the whole one. I call this A, I call this B, yeah? Shortcut. So 1 times negative 1 times negative 7. By the property that the determinant of upper triangular matrix is the product of the diagonals. Somehow you have to write that because the question is found using property. Otherwise you will lose marks. Probably anyone will get the right answer, but not the right calculation or computation. Okay. So basically, we are using ERO to make it to other properties and then find the determinant. Not to make it to other properties, but to use to be able for us to use the property. To use ERO, so we are able to use the property, which is actually to make it diagonal or upper triangular matrix. Lower, not really, right? Our ERO is for the upper triangular matrix. Paham ya? All right, thank you for the question. Okay, let me go back and see whether
Prof.
Ya,
Rizal ada soalan.
ya. Let me see just now for the. Saya tengah nak cari yang determinant tadi. Sekejap. Yeah. I remember I put this under theorem 1.2 when I mentioned about the diagonal matrix. This is also true for upper triangular matrix or lower triangular matrix. Okay. Okay, Sharizal. What's your question? Oh, ada silap kira. Ada silap R3 plus R2. Oh, this one, yeah. Ni, I just add. Betul? Betul? Okay, R3 plus R2. This plus this. So I get negative 1. This plus this. So I get negative 1. Okay. Okay, so negative 5 R2 plus. So this is 5 minus 2 is 3. So this is 3. Yusof ada Yusof? Tak dengar pula suara Yusof.
Ada madam, tengah fokus.
Tadi salin ke tahu salah?
Question pass.
Ada lagi silap ke tak? Ada tak? Confused, not sure.
That one should be 1, yeah.
Yeah. This one, I don't want to use anything else. So I just want this to be 1 or negative 1. So I just add. So this is negative 1. I just add This is 1. Right? Okay, so I get R3 plus R2. And then for this one, I want to do 0. So I multiply by negative 5. And then I get 5 and then add negative 5 back to negative 7. Jawapan betul. Okay. The moral of the story is check your calculation every time. Yeah, okay. Okay, so you have to try and do this one yourself. Okay, so yes, the answer is +7, negative times negative. These are actually common mistakes, yeah? This is very, very common. That's why you need lots of exercises. So you are used to multiplying and adding, And many times the silly mistake or common mistake is the adding part, the multiplying part, something that you do in your head. Okay, so unfortunately, if you, in the last chapter, which is normally the last question in your final, which is normally 20 points out of 100 in the final, you have to find and use the determinant to solve something. You imagine if you miss the determinant part, you lose 20 points. That's why. So making sure you check, you check your answer before you move on. Okay, I will stop here because I want you to try this. Okay, and then later on when you finish, you can just put the answer in the WhatsApp group, just the answer. Okay, using your ERO, you can put in there. I don't want just to make sure I know you're done with this one. So what you do is you do ERO, make this, because there is no similar, right? Otherwise you can see same column. You make this and this 0 using this, easy, right? You don't need to multiply by -1. You can just, you want 1, you can just add, but no need because this is easy number. You can just add, making the 0, multiply by 3 and add, multiply by 2 and add, and try to reduce. Okay, so any question? Any other question? Our next meeting is next Tuesday. Yeah, no meeting on Sunday. So those who will be Muslim who will start fasting on Sunday, happy Ramadan. Okay. Then we have actually more time because we don't have to worry about eating during the day, right? Boleh stop.